Look at this image. These towering columns of gas and dust stretch for light years across space. They look like something out of a science fiction movie. But this is real. This is the Eagle Nebula. And right now, inside these pillars, something extraordinary is happening. Stars are being born. In our last video, we talked about how stars die, in spectacular supernovas that can outshine entire galaxies. But today, we're going back to the very beginning. How does a star come to life? What does it take to ignite a sun? The answer involves clouds bigger than you can imagine, forces that battle each other for millions of years, and a moment of ignition so powerful it lights up the darkness of space forever. Let's go. Every star you've ever seen in the night sky, including our own sun, started its life in a nebula. A nebula is a massive cloud of gas and dust floating in space, mostly hydrogen, with some helium and traces of heavier elements. These clouds can stretch for hundreds of light years. To put that in perspective, if our entire solar system were the size of a coin, one nebula would be the size of a continent. For millions of years, these clouds just float, slowly drifting through the galaxy, cold and still. But then something disturbs them. It could be the shockwave from a nearby supernova, the death of an old star literally triggering the birth of new ones. The universe recycling itself. It could be two galaxies colliding, sending gravitational ripples through their gas clouds. Or it could simply be the slow gravitational pull of nearby matter, building up over millions of years until the cloud can no longer hold itself apart. Whatever the trigger, the result is the same. Parts of the nebula start to collapse inward under their own gravity. And once that process begins, there's no stopping it. As gravity pulls the cloud inward, something fascinating happens. It starts to spin. Think of a figure skater pulling their arms in. They spin faster. The same principle applies here. As the cloud shrinks, it rotates faster and faster. The material doesn't all fall straight to the center. It flattens out into a spinning disk, called a protoplanetary disk, with a dense, hot core forming at the middle. That central core is called a protostar. It's not a real star yet. It's a clump of gas that's getting hotter and denser by the minute as more material rains down on it. For thousands, sometimes millions, of years, the protostar keeps growing. The temperature at its core climbs steadily, from a few thousand degrees to tens of thousands to millions. The pressure builds, the density increases, atoms get squeezed closer and closer together. And then, at a core temperature of about 10 million degrees Celsius, something incredible happens. Nuclear fusion ignites. Nuclear fusion is the process where hydrogen atoms are crushed together under extreme heat and pressure until they fuse, merging into helium and releasing an enormous amount of energy. This energy is what makes a star shine. It's the light that travels 93 million miles to warm your face on a sunny day. The moment fusion begins, a new star is officially born. And that energy pushes back against gravity, creating the same perfect balance we talked about in our last video. Gravity pulling in, fusion pushing out. A star in equilibrium. The newborn star also blasts out powerful jets of material, called stellar winds, that blow away the remaining gas and dust around it. For the first time, the star is visible. It has cleared its own neighborhood, and it shines into the darkness of space. A sun has been born. Here's the thing. Not all stars are created equal, and the single most important factor in a star's life is how much mass it was born with. Small, low-mass stars, called red dwarfs, burn their fuel incredibly slowly. They're cool, dim, and reddish, but they live for an almost unimaginable amount of time. Trillions of years. The universe isn't even old enough for the first red dwarfs to have died yet. Medium-mass stars, like our sun, burn steadily for around 10 billion years. They shine yellow-white and are the most common type of star we know of that can support life on nearby planets. Massive stars, the blue giants, burn so hot and bright they consume their fuel in just a few million years. They live fast and die violently. These are the stars that end their lives as supernovas, and sometimes as black holes. A star's color is directly tied to its temperature. Blue stars are the hottest, over 30,000 degrees at the surface. Yellow stars like our sun are around 5,500 degrees. Red stars are the coolest, around 3,500 degrees. So the next time you look at the night sky, you're not just seeing points of light. You're seeing different temperatures, different ages, different life stories, all written in color. Our own sun was born about 4, 6 billion years ago, roughly a third of the age of the universe, it formed from a giant molecular cloud in one of the spiral arms of the Milky Way. A nearby supernova is thought to have triggered the collapse, meaning our Sun, our Earth, and every living thing on this planet owes its existence to the death of another star. The heavier elements in your body, the calcium in your bones, the iron in your blood, were forged in the cores of ancient stars that exploded long before our Sun was born. You are quite literally made of stardust. Our Sun is now about halfway through its life. It has roughly 5 billion years left on the main sequence before it too begins to change. But that's a story for another video. Stars are not permanent fixtures of the sky. They are born, they live, and they die, just like everything else in the universe. They begin as invisible wisps of gas in the cold darkness of space. They collapse, heat up, and ignite, becoming the brilliant suns that light up galaxies. And in that process, they create the very elements that make planets, oceans, and life possible. The pillars of creation. We saw at the start of this video, stars are being born inside them right now. New suns igniting for the very first time in a nebula 6,500 light-years away. The universe is not a static, empty place. It is alive, constantly creating, destroying, and creating again. Next time, we'll follow these stars into old age. What happens to red giants, white dwarfs, and what our own sun's final chapter looks like. If you enjoyed this video, please leave a like. It genuinely helps the channel grow. Subscribe if you're new, and drop a comment. Which star fact surprised you the most today? I'll see you in the next one. Keep looking up.